HHpred, my favorite annotation tool, bar none. How's it work? Same as everything else. Here's the big box. You paste your thing into the big box. And then once you've pasted that sequence in there, you got a couple of options. If you want to align two sequences, you click that. It'll open a second window. You put your second sequence in there. If you just want to compare this against the database to try and figure out what is my protein, then there are three databases that are actually worth using. The first is the default database, which is the Protein Databank's 70% identical or less set. It's also worthwhile putting in the NCBI conserved domains for things that exist but haven't been solved structurally. And PFAM is another database that has things that are similar to that, but sometimes you'll find that a particular gene will show up in one database and none of the others. So it's worth running all three, and you can run them all together or you can run them separately as you like. You don't ever need to select a proteome. That's if you want to blast it against like only things in a mouse or something like that. So you paste your proteins in there, rather your protein in there, or your protein multiple sequence alignment with all of them in Pearson FASTA format. And it will check either your alignment or your individual sequence. So bam, hit submit. So let's go to our actual results. Oh, and this is a list over on the side of all your recent searches. And so this is the one I'm actually on. And so clicking that would bring us back to this page. Here's what a result looks like. You're going to see that we have the same color scheme that we had in BLAST and HHblitz, where we're going to have little matches. So this thing on the top, this is your sequence. And so it goes from 1 to, it looks like 1865 is how much I put in there. And then underneath, these are potential explanations for the sequence that's above. So for a particular region from, let's see, about 103 to about 897 would be this one. Let's click it and go see. Sometimes you click it, it takes a second, there we go. And so this is what we're actually looking at. And so this is the exact position. So it was 208 exactly. And you can see here are at the top are your sequences. We've got it on wrap mode so that this set of lines, so this entire block of, what is it, like 10 lines, 9 lines, stops here, but then it continues down here. So this line continues there. This line that has an N on it continues with this line that also has an N on it, etc. Just like that. If that's breaking your brain, click wrap sequences. It'll unwrap them. And then you'll see the sequences and you can scroll them to the side. It's the same thing. It was just formatted so it would fit on our screen before. And also it by default is going to color the sequences. Now some of these colors are rather hard to read. I think particularly the very light green on a white is almost impossible. And so you can turn off the sequence color if you want, and then you get nice black and white on there. But the sequence color is sometimes helpful because it's coloring amino acids of a certain type in a certain color. So all the hydrophobic ones are coming up green, for example. That can help you spot patterns, which is part of what this is doing. So you've got your sequence up here, the query sequence. You've got the target sequence, the one that it found down here. In this case, it's a CD, which means that's an NCBI conserved domain that we matched, although we also have matches for many other things up here. So you'll have matches like this 7K3T is a match for a crystal structure, and there are going to be matches for cryo-EM structures in there as well. If it starts with a name like herpes, whatever, that's going to be a PFAM family. Like here's a PFAM one. These that start with CD are NCBI conserved domain hits. And frankly, some of these will be redundant, and we really need one good explanation for each thing. That's all. So there we go. That's a big long thing. Looking great. How else? What else have we got going on here? We also have whether they match or not. So that's going to be very similar to BLAST. So a line is perfect match. A plus is an okay match. A dot is a not very good match. And nothing is like a sequence that's present in one side and not the other. So you can't even make a comparison. And the other thing you need to know is that we have structure predictions on here. So at the top, these are the predicted structure. So there we go, all the way along there. E means extended, so that's a beta strand because they're all stretched out and extended. H is a helix, so those are alpha helical. And this is a prediction, SS predids. HHpred is secondary structure prediction. Down at the bottom, 7K3T, that's an actual, it looks like a PDB code because it is a PDB code for the sequence, rather the structure 7K3T. And so this one we actually know the structure for. So this is the structure as annotated. If they ran this structure through the predictor, this is how the predictor would have seen it. So it's going to include both those things in the profile. And from that, you can see they're very similar, it's going to look for a match between not just amino acids, but also conserved amino acids and also conserved structures with amino acids at the same time. Very powerful search method for finding very difficult to find things. And with hot colors are better. Those are the ones that have the best stats. The cool colors are usually not very good. The numbers we want to look for are the probability. That's an internal marker right here, but higher is better. And generally, you want that to be at least above 50%. E value is the one that I really like to take home, and this is like your chance of error. So that's an 8 times 10 to the negative 192nd power, and I think it only goes up to around negative 200th power, so that's pretty near the maximum confidence this tool could actually generate. And then the other things are internal measures that it's going to use to tell you like what it's been doing. You can show the top 25, you can show all the entries at the same time, either way you like. And yeah, so this big thing is a large explanation that's actually several proteins together. The little things underneath are explanations for each individual region. So like for the region from about 565 until about, let's see, it's not 186. Okay, that one stopped responding, but it's probably around 600, something like that. And if we want to see the exact thing, we could, of course, hover over it and click down there. Now, the only thing that'll throw you off is if you go and you click one of these links, it does not take you down to the alignment. It'll actually take you to the structure that it comes from, the conserved domain or the actual PDB structure. And if you don't want to go there, then you're just going to click your back arrow and you will go back. Here is the structure page from the PDB, and yeah, you can see everything that's got going on there. And so this one is a ribosome with the SARS coronavirus messenger RNA on there. So it basically has the entire sequence of SARS-CoV-2. There we go. That's the way this works.